Hello there. Welcome to A Sleepy Scientist. This is your calm and quiet spot in space, where being curious feels peaceful, and science gently helps you get ready for sleep. Before we start our trip through the stars tonight, I'd love to know, where in the world are you watching from? And what time is it right now for you? Tell me in the comments below. I'm always amazed by how many of us are floating along together from all over the planet. And if you like our journey tonight, maybe give this video a gentle like, and maybe subscribing up for the channel. That way, you won't miss our next time looking at the stars. It helps more sleepy brains find their way here. Now, tonight's story is a really pretty one. It's about how galaxies, those huge cities made of stars, are born from darkness and dust. I really hope it's not so interesting that it keeps you awake, but if it does, well, at least you'll know a bit more about the early universe before you have your morning coffee. So, get comfy. Let your shoulders relax. Breathe slowly. You're about to float through 13.8 billion years of space history. No need to hurry. The stars will wait for you. Let's start. 3.8 billion years ago, the universe was super tiny. Not just small like a bedroom with no windows, but so small you can't even imagine it. It was hotter than the middle of a star and squished tighter than a scientist's calendar when they're hoping for a big award. And then, in a moment we can't fully understand, it all began. It wasn't really an explosion, even though we call it the Big Bang. It was more like a really fast, smooth swelling. Space itself stretched out in every direction, faster than light. Think of it like a balloon blowing up super fast with a leaf blower set to space speed. Nothing was flying through empty space. Space was the stuff, and it was making itself as it went. In those first super quick moments, the universe was like a boiling soup of tiny, tiny pieces. Quarks bumped into gluons, photons zipped around like wild little kids, and gravity, which is always very patient, quietly started making plans. It was messy, blindingly hot, and super uncomfortable. Not a good place for looking at stars or toasting marshmallows yet. But this early universe, even with all its craziness, had a lot of possibilities. Hydrogen and helium, the simplest and lightest bits, formed. They were like cosmic Lego bricks, snapping together from the buzzing mess. These simple atoms would go on to build everything. Stars, planets, people, pet lizards, and of course, galaxies. About 380,000 years after the Big Bang, which is like a tiny blink in space-time, something really amazing happened. The universe cooled down enough for those atoms to grab onto tiny electrons, making the first normal uncharged atoms. Light, which before was bouncing around like a firefly trapped in a jar, was suddenly free to travel. This moment is called recombination. It made the cosmic microwave background, a soft glow left over from the Big Bang that you can still feel humming through the universe today. If your eyes could see microwaves, the whole sky would glow with the light from that old fire. But even with the glow, there were no stars. No galaxies. Not yet. The universe at this point was a dark, expanding cloud of gas and possibility. If you could float through it, you'd see nothing but tiny ripples, little bumps in how smooth everything else was. These ripples were everything. They were like whispers of tiny wobbles from the very first moments, stretched across space by the superfast growth. Some spots were just a tiny, tiny bit thicker with stuff than others. Barely a difference, really. But gravity noticed, and gravity doesn't forget. Over time, those thicker spots of hydrogen and helium started to pull in more and more stuff, slowly and gently. They gathered like tiny drops of dew forming on a spiderweb in space. These clumps, which would become galaxies later, were totally invisible to our eyes, if eyes had even been around then. But they were already getting ready for all the amazing show to come. It feels a bit weird to think of the universe as quiet, but in a way, this time was quiet. No light from stars, no glowing galaxies, just the faint murmur of stuff falling into itself. It was a time of stillness before the big action, like taking a long breath in before the universe let out the light of stars. And yet even now, with all our telescopes and math, we're still figuring out how it all happened. How did these tiny wobbles lead to the huge, amazing spiral galaxies? Why did some parts of the universe become busy places with lots of stars, while others stayed huge, dark, empty spots? The answers are written all over space, in every glowing cloud of gas and every old star cluster. We just have to keep listening. And so, the universe grew. Dark matter, which is like the invisible bones of reality, started to pull and shape what was forming. Hydrogen gathered into long lines. Gravity whispered, and space listened. Soon the first stars would light up. The darkness would end. But for now, everything was ready. The universe was no longer just getting bigger. It was starting to become. The stars hadn't arrived yet. The galaxies were still sleeping. And for a few 100 million years, the universe stayed wrapped in what we now call the cosmic dark ages. Even, though it sounds spooky, there were no knights or castles here. No dragons, unless you count the kind made of hot gas and hydrogen. This was darkness in its purest form. A universe full of stuff, but not yet light. After the Big Bang's super bright beginning and the soft glow of the cosmic microwave background, things got quiet. Plain hydrogen gas filled space like a huge, invisible fog. There were no stars to shine through it, no galaxies to twinkle far away. The universe had gone dim, not because it ran out of energy, but because it hadn't figured out how to turn the lights on yet. Imagine floating through this time, an endless expanding ocean of cool hydrogen and helium. Every now and then, a lonely electron floating by like a lazy jellyfish. There's gravity, pulling ever so gently on the gas, making clouds here and there. But everything moves super slowly. Not that time mattered much. No clocks, no days, no sunrises. Just the slow, patient gathering of stuff in a universe not yet in a hurry. Yet something amazing was quietly happening in this shadowy silence. The foundation for everything we know was being built. You see, during the super-fast stretching, right after the Big Bang, tiny quantum wobbles were pulled across space. These little bumps in how much stuff was packed together weren't much to look at. But over time, gravity noticed. Where stuff was a tiny bit thicker, it started to pull more stuff in. Over hundreds of millions of years, these ripples grew into long threads and knots, what we now call the cosmic web. Think of the universe like a giant sponge, or maybe a 3D spider web, held together by threads of dark matter and gas. These threads are where galaxies would eventually form, pulled into place by gravity's steady hand. The empty spaces in between are voids, giant lonely stretches of almost nothingness where almost no stars will ever shine. At the middle of it all was a silent helper, dark matter. It doesn't glow, it doesn't reflect light, and it doesn't bump into light at all, which makes it super hard to study and kind of boring at parties. But dark matter was totally needed. Its pulling power shaped the mainframe of space, pulling normal stuff, the hydrogen and helium gas, into place, like the hidden frame under a painting. Without dark matter, the universe might have stayed a foggy cloud forever. Now, if you're still awake, and if you are, I'm really impressed, you might be wondering why it took so long for the first stars to show up. Well, building a star isn't as easy as throwing gas into a blender and flipping the sun switch. Hydrogen had to fall into spots that were dense enough for gravity to take over, squeezing it until it got super hot, millions of degrees. Only then could fusion begin, the special dance inside atoms that makes a star light up. But the early universe wasn't in a hurry. It let gravity work at its own pace, gently pushing the gas into thicker and thicker clouds. Slowly, Patiently, these clouds fell in on themselves because of their own weight. Somewhere in one of those thick, invisible knots of stuff, the first spark would light up, a single point of light in an ocean of darkness. And when that happened, everything changed. But here, during this long, quiet time, the universe was still, taking a deep breath, like an orchestra getting ready before the first note. The pieces were in place, but the music hadn't started yet. No galaxies, no stars, just a growing feeling that something beautiful was about to happen. And maybe that's the nicest thing about this time. Even in the darkness, the universe was never truly still. Under the silence, it was dreaming, getting organized, getting ready. The light was coming, and then it happened. Somewhere deep inside a shrinking cloud of hydrogen and helium, gravity squeezed harder. At the center of that thick, invisible swirl, the pressure went way up, and temperatures climbed to millions of degrees. Atoms were pushed so close together that they started to change. And in that moment, probably not noticed by anyone, not a big deal at the time, a star was born. The first light since the Big Bang. These weren't just any stars. They're called population 3 stars, and they were nothing like what we see today. They were super huge, not stable, and incredibly hot. They formed in the cleanest conditions the universe has ever known. There were no heavy things, no carbon, oxygen, or iron, just hydrogen, helium, and a little bit of lithium, all left over from the Big Bang. This made these stars burn hotter and faster than the ones we know now. Some might have been hundreds of times bigger than our sun, living short, wild lives before falling into black holes or blowing up in super bright explosions. If you were floating nearby, though, let's be honest, you'd be very, very crispy. You'd see these first stars lighting up their surroundings like campfires in a huge space forest. One by one, their light poked through the ancient fog of hydrogen that had filled the universe since the beginning. Slowly, the darkness started to lift. This time is called cosmic reionization. And while it sounds like something a bad guy in a sci-fi movie might do with a laser gun, it was a peaceful, though dramatic, process. The bright ultraviolet light from those newborn stars started to pull electrons off the neutral hydrogen around them, charging it up and making the universe clear again. It was like someone had opened the windows of a space greenhouse and let the light flood in. From our view, billions of years later, we can't see these first stars directly. They were too quick, too far away, and their light too faint. But their signs are everywhere. They changed the universe from cold and dark to warm and glowing. They filled space with the first heavy ingredients, the building blocks for everything more complicated than hydrogen, including you, me, and the cup of tea you might be drinking right now. In a way, these stars were the universe's first artists, drawing the outlines of galaxies on the blank canvas of space. But galaxies still hadn't formed. Not quite. These early stars were often spread out in small groups, held together by gravity, but not yet forming the big, swirling cities of stars we see in the night sky today. These were more like small villages, maybe proto-galaxies, just trying out how to be structured and stick together. Yet the ingredients were coming together. As these huge stars ended their lives in huge explosions, they shot out heavier things into the gas clouds around them. Those richer clouds cooled better, collapsed faster, and formed stars more easily. The next group of stars, population 2, started to show up. A bit smaller, a bit more stable, and already more familiar. And so, the great space cycle began. Gravity pulls in gas, stars are born, they shine, die, and scatter their rich insides, letting even more stars form. Each group builds on what was left by the last, adding layers of complicatedness like space dust settling. You might wonder, how do we know all this happened if we've never seen these old stars? The answer is hidden in patterns of light, like ghostly fingerprints left on the window of space. By looking at the oldest galaxies, the chemical signs in old stars, and the faint glow of the cosmic microwave background, astronomers can put together the universe's childhood in amazing detail. It's a bit like figuring out the history of a forest by looking at its oldest trees, its dirt, and which way the wind blows. The clues are tiny, but they're there. And recently we've started to get quick peeks with telescopes like James Webb. We're finally starting to see some of the very first galaxies taking shape. Small, messy, glowing clumps of stars from just a few 100 million years after the Big Bang. We're looking into the nursery where the first light bloomed. It's really humbling. These stars lived and died before our sun's family was even a dream. Their light traveled across space for billions of years, past clashing galaxies, past wandering black holes, past our growing Milky Way, until it gently landed on the mirror of a telescope pointed at the sky. And now it rests in your mind, in the quiet of your evening, as you get ready to sleep. The universe, once dark and quiet, had lit its first lanterns. The night had ended, and the time of galaxies was about to begin. The universe was glowing now, not super brightly, more like the first hint of dawn on a cold morning. The stars had arrived, their light clearing the fog, warming the silence. But they were spread out, alone, flickering across the dark, like distant campfires with no cities, no roads, just lonely pockets of light floating in the emptiness. But gravity had other plans. Those scattered stars weren't just floating randomly, they were being pulled together by invisible threads. Everywhere you looked, or would have looked, if you'd had a way to see in ultraviolet and the patience of a space being, small clumps of stars were coming together. Gravity was quietly weaving them into bigger, more complicated structures. The villages were becoming towns. The towns would become cities. And these cities, these proto-galaxies, were the first rough drawings of what we now call galaxies. It didn't happen neatly. There were no building plans, no space engineers drawing out spiral arms with rulers. It was messy. Clumps crashed, joined together, pulled each other apart, and joined again. The early universe was a rough neighborhood. Gas clouds smashed into each other, stars were thrown from one group to another. Some early galaxies formed quickly, getting big by sucking up nearby gas and eating their neighbors. Others got stuck, left alone in quiet corners of space like shy kids at a party. At this stage, galaxies didn't look like the pretty spirals or huge round shapes we see in shiny telescope pictures. They were uneven, messy, unpolished. More like space blobs than the perfect beauties you might imagine. And yet, even in their mess, they were growing. Slowly, their shapes started to become steady, pushed by gravity and shaped by where they were. Much of this early building was affected by something even bigger, the cosmic web. You can picture it like a huge 3D lace made of stuff, woven across the universe. Thick knots where threads of dark matter crossed became the busy centers, places where galaxies would gather like seeds finding the best dirt. Long threads stretched between them, pulling galaxies along invisible rails of gravity. And in between these threads were huge, empty voids, creepy and quiet, where few galaxies would ever form. It's in these thick crossing points that proto-galaxies had the most to gain, and the most to fear. When you have a lot of gas and gravity in one place, things tend to get a little dramatic. Galaxies would smash into one another, a slow-motion dance that could take hundreds of millions of years. These weren't violent crashes like you might think. Stars themselves are so far apart that most didn't hit anything at all. But their gravity fields did get tangled. Pulling forces twisted galaxies into strange shapes. Streams of stars were pulled like taffy, trailing behind their original homes. Gas clouds crashed into each other, squeezing hard, and often starting a huge burst of star formation. These starburst galaxies can make stars dozens or even hundreds of times faster than usual. It's like a space baby boom, started by the chaos of gravity's upset. Some of the most beautiful and messy galaxies we've seen are caught in the middle of crashing. The antennae galaxies, for example, two spirals joining, show long, curly arms of stars and super bright areas where new stars are forming. They're a picture of what happens when galaxies don't stay in their own space. And eventually, the two galaxies will settle into one. That final thing often isn't a spiral anymore. Spiral shapes are delicate, too easy to mess up. After a big crash, the result is usually a large, round galaxy. The orderly paths of stars get all mixed up, and the gas, much of it used up in the starburst or thrown out into space between galaxies, isn't enough to form beautiful new arms. This is how many of the biggest galaxies in the universe came to be. Not from peaceful gathering, but from slow-motion crashes, like cities built by overlapping giant Earth plates. But this isn't just old history. Our Milky Way isn't just watching all this. It has its own crashes to deal with right now. Our galaxy is slowly joining with several smaller dwarf galaxies. The Sagittarius dwarf galaxy, for instance, is slowly being pulled apart and swallowed. Its stars now follow ghostly paths through the Milky Way's outer glow. Other small galaxies are on similar journeys, being eaten, reshaped, and folded into our own. And then there's Andromeda, our closest big neighbor. The Andromeda galaxy is on a crash course with the Milky Way. They're about 2.5 million light-years away, but moving towards each other at about 110 kilometers per second. That might sound fast, but in galaxy terms it's a slow and graceful approach. The crash won't happen for another 4 billion years or so, but when it does, the result will be amazing. What will happen to us? Surprisingly little, at least for our solar system. Again, stars are so far apart that hitting each other directly is unlikely. But the night sky will change. Over millions of years, Andromeda will get bigger and brighter, eventually filling the view. The two galaxies will twist around each other, join and settle into a new shape, possibly a giant round galaxy. Astronomers have even given the future merge a loving nickname, Milkomeda. Yes, really. Science names can be a bit silly sometimes, but even before that grand dance begins, crashes keep happening all around us. Galaxies in thick groups are constantly bumping into each other, their shapes getting pulled, their gas stirred up. It's a part of the life cycle of the universe. Galaxies aren't still islands. They grow, change, and make friends, just like everything else in nature. What's especially cool is that these interactions aren't just about breaking things. In many cases, they create new things. Merges can restart star formation, feed the black holes in the middle, and mix up the stuff in galaxies in ways that lead to totally new shapes. Like cutting a tree or mixing two colors of paint, the result is something new. Messy at first, but often more lively than before. And in this always changing space, crashes are not rare. They are the normal thing. We usually think of the universe as calm and never-changing, like an eternal night sky sprinkled with still stars. But it's alive. Galaxies are floating, falling into each other, mixing their light, their stars, and their stories. Even now, somewhere out there, two galaxies are starting their long, slow dance. One day they'll crash, not in violence, but by joining, and a new galaxy will be born, just as it always has been, just as it always will be. To look into space is to look into time. It's one of the quietest, most amazing facts about the universe. Every star you see in the night sky, every galaxy caught by a telescope, isn't showing you how it looks now, but how it looked then. Light, even though it's super fast, still takes time to travel. And space is huge, very, very huge. So when we look up at the stars, we are literally traveling through time. Take the sun. The warm light touching your face during a late afternoon. Walk left the sun's surface about 8 minutes ago. That starlight is already 8 minutes old by the time it gets to Earth. You never see the sun as it is. You see it as it was. Go beyond our solar system, and the time delay gets bigger. The light from Alpha Centauri, the closest star system to us, is over 4 years old. And the glow of the Andromeda Galaxy? That's ancient light. It started its trip toward us more than 2.5 million years ago, long before the first humans, long before writing, long before the wheel. That gentle shimmer in the sky is a memory, a whisper from a past so far away it happened before everything we know. But we can go even further back with the right tools. We can look back billions of years, almost to the very beginning. The deeper we look, the further back in time we go. It's like peeling back the layers of space history, one tiny bit of light at a time. This is where telescopes become time machines. Take the Hubble Space Telescope, for example. Launched in 1990 and flying high above Earth's air, Hubble has shown us things we never thought we'd see. One of its most famous things it did is the Hubble Deep Field. It was a simple idea, really. Astronomers pointed Hubble at what looked like a totally empty patch of sky, a part so dark and blank that it seemed like nothing was there. They let it stare for days, and when the pictures came back, that nothing became a sea of galaxies. Thousands of them, each with billions of stars, all packed into a tiny speck of sky, smaller than a grain of sand held at arm's length. Some of those galaxies were over 13 billion years old. We were looking back in time almost to the moment when galaxies first started to form. That light had traveled for almost the entire age of the universe just to reach us. It had crossed distances we can't imagine, passed by countless wonders, and finally landed on Hubble's mirror, leaving behind a faint but lasting trace. Now we have an even more powerful time machine, the James Webb Space Telescope. Launched in 2021, Webb can see even deeper into the past. Not just because it's bigger, though it is, with a mirror over 6 meters wide, but because it sees in infrared light. That's super important. As the universe gets bigger, light from far-off galaxies gets stretched, like pulling taffy, making it shift to longer waves. This is called redshift, and it means that the earliest galaxies now shine mostly in infrared light. Hubble could see a little of that light. Webb was built to soak it all in. Already it's showing us galaxies that existed just a few 100 million years after the Big Bang. Some are small, messy, and wild, just as we'd expect. Others are surprisingly grown up, like full cities appearing right after the first huts were built. These discoveries are changing how we understand how fast galaxies formed, and maybe even rewriting parts of space history. And here's the coolest part. The farther away a galaxy is, the younger it is in real life, but the older it looks to us because we're seeing it as it was billions of years ago. You might think then that we're always looking into the past, and that's true, but it's also how we learn. We can't rewind the universe, but we don't need to. It has already sent its memories to us, one bit of light at a time, and we are catching them, slowly, quietly, with glass and gold and great patience. In a way, this is what science often is, listening to the past with better and better ears. Of course, all this looking back has its limits. There's a point in time we can't see past. The cosmic microwave background, the leftover glow from the Big Bang. It's not that there's nothing before it, but that the universe was cloudy before then. Light simply couldn't travel freely. It was trapped, scattered like fog in a thick forest. Only after the universe cooled and atoms formed did light finally break free and start its long trip to us. That's our cosmic horizon, the edge of what we can see. And beyond that, mystery, possibility, questions we're still trying to answer. For now, what we do have is amazing. Every picture from Webb, every frame from Hubble, is a photograph of the past. A snapshot of a moment so far away it feels like a made-up story. But it's not. It's real. That light is real. It touched something once, a star, a galaxy, a cloud of gas, and now it touches you. So the next time you stare into the night sky, remember this. You're not just looking up. You're looking back, way, way back. The stars are still shining, but many of them are shining from a time when Earth was young, when there were no eyes to see, no names to give them. And yet their light kept going, crossing space and time to find you here now. The universe doesn't just tell stories, it remembers them. We've traveled far, from the very first tiny whispers of stuff to the huge spirals and glowing middles of galaxies. We've watched the universe light up, get organized, and change. And now, as we float into the present, we find that the universe is far from done. Galaxies are still forming, still joining, still reaching toward each other across the huge emptiness of space. Because galaxies, like people, tend not to live alone. Instead, they gather. They form groups, clusters, and even superclusters, huge structures so big they are hard to imagine. Our own Milky Way is part of one such gathering, the local group. It's a pretty quiet spot in space, made up of more than 50 galaxies. Most of them are small and dim dwarf galaxies, orbiting the bigger ones like tiny space moons. The local group's two biggest members are, of course, us and our neighbor, the Andromeda Galaxy. We're the twin giants of this little galaxy neighborhood, slowly spinning toward each other. We've already talked about our future merge, but for now the two galaxies keep a respectful distance, close enough to notice each other, far enough not to bump elbows just yet. Around us are lots of smaller friends. Some, like the large and small Magellanic Clouds, are easy to see from the bottom part of the world, and are themselves being pulled into our spiral arms. Others, like the Draco Dwarf or the Ursa Minor Dwarf, are harder to see, faint groups of stars barely holding onto their names as they orbit through our galaxy's invisible dark matter halo. Groups like ours are common, but they're just the start. Zoom out even more and you find galaxy clusters, groups of hundreds or even thousands of galaxies held together by gravity. The Virgo cluster, for example, is just beyond our locals group, and it's full of spirals, round ones, and every shape in between. Here, galaxies aren't politely far apart. They crowd together, interact, and often crash. In these places, you can almost feel the tension, gravity's tug-of-wars happening across millions of light-years. These clusters are inside even bigger groups, superclusters. The Laniakea supercluster, our space address in the biggest way, stretches over 500 million light-years across and has about 100,000 galaxies. That's right, 100,000 galaxies, each with billions of stars, all floating together through space, following gravity's pull through a web we're only just starting to map. And even that is just one thread in the larger cosmic web, the huge structure that forms the skeleton of the universe. Galaxies are not sprinkled randomly through space. They form patterns, long threads, flat sheets, and knots, like a huge foam stretched across a dark sea. These structures, started in the very first moments after the Big Bang, have been shaped over billions of years by the gentle pushes of dark matter and the steady pull of gravity. In between these threads are voids, huge empty areas where few galaxies exist. Some are tens of millions of light-years wide, dark, and quiet, with only a rare, lonely galaxy floating through like a ship at sea. It's in this difference between crowded clusters and huge empty spaces that the shape of the modern universe shows itself. But not everything is growing. Not everything is rushing forward. There are signs that the universe's grand dance might be slowing down, not in movement, but in creating new things. Many galaxies, especially the big, old, round ones, are no longer forming stars. They've used up or lost the gas needed to make stars. We call them red and dead, not because they're not alive, but because their old stars glow a soft reddish light, and no new stars are taking their place. Even our own Milky Way is making fewer stars than it used to. It's not finished, not by a long shot, but the time of superfast star birth is behind it. We're in a calmer, more thoughtful part of galaxy life. And the universe itself? It's getting bigger, faster and faster, thanks to something we still don't fully understand. Dark energy. This mysterious force is pushing galaxies away from each other at speeding up rates. Over the next few trillion years, it's possible that galaxies not held to us by gravity will disappear from view entirely, their light stretched until it can no longer reach us. The universe will get colder, quieter, and more alone. But don't worry, we've got time. A lot of time. For now, galaxies keep bumping into each other, changing and surprising us. With telescopes like Hubble, James Webb, and those still to come, we're looking deeper into space and further back in time than ever before. We're catching the echoes of galaxies being born, the ripples of crashes, the faint sparkle of newborn stars in galaxies so far away their light left before Earth even had oceans. Every night sky is filled with those echoes. Every glowing dot is a story. Some are just starting, others ended long ago, but all of them are part of this huge, beautiful design. The visible universe is still painting itself even now. Galaxies are no longer just mysteries. They are friends, teachers, reminders that even in a universe so big we can't hold it in our minds, we belong to it, and it belongs to us. And now, after billions of years and billions of light years, we've come to the end of our journey. We've floated from the birth of the universe to the birth of galaxies, from the dark ages to the first light. We've watched stars light up, gather into cities of fire, and spin through spirals shaped by invisible hands. We've seen galaxies crash, join, fade, and grow old, quiet giants in a living space that never stays still. We've traveled through the Milky Way, our own galaxy home, and felt the pull of black holes and dark matter, the quiet builders of all that we see. And we've looked back in time, really looked, catching ancient light that traveled across the entire universe just to meet us here now. It's amazing, isn't it? To know that the stars above you are not just tiny lights, but memories. That galaxies are not still pictures, but stories still happening. And that everything around you, your hands, your breath, the thoughts floating through your head, was made in the heart of a star that died long ago. You are literally made of galaxy stuff. You are part of the story. And maybe, just maybe, that's why we find the night sky so comforting. Why something inside us gets quiet when we look up. Because some old part of us remembers what it feels like to float through starlight. So now, as your eyes get sleepy and your thoughts get softer, I'll ask again, just like I did when we started. Where in the world are you listening from tonight? And what time is it where you are? Drop a note in the comments if you'd like. I love hearing where these little trips are happening all across the world. It reminds me how connected we are by wonder, by being curious, and by stardust. And if you enjoyed floating through space with me tonight, think about leaving a like or signing up for more sleepy science. There's a whole universe waiting for us, and I'd love to explore it with you. But for now, let's rest. Let the stars keep watch and let the galaxies keep spinning, just as they always have. Good night, fellow traveler. You have a home among the stars.